Now, most of y'all have the note sheets, and you can see the first thing on there is talking about properties of parallelograms. Now, before we can really talk about the properties of a parallelogram, we need to know what a parallelogram is. A parallelogram is a quadrilateral, so a four-sided figure with two sets of parallel lines. A parallelogram is a quadrilateral with two sets of parallel lines. Now, we're going to be talking a lot about quadrilaterals, four-sided figures in this chapter. But as we start talking about them, we're going to get more and more specific details about them. So really, we consider the term quadrilateral, four-sided, as the most general term. Quadrilateral is the most general term we can have for a four-sided figure. So if we don't know anything about it besides the fact that it has four sides, we're going to call it a quadrilateral. But as soon as we find out that it has two sets of parallel lines, we're not going to call it a quadrilateral anymore. We're going to call it a parallelogram. Because we're always going to classify or name a four-sided shape by the most appropriate name that we have, whichever one best fits the data or the information that we have. As the more information we have or the more specific details we have, we're going to name it based off that. This is also why when we had the first chapter where we talked about four-sided figure, name a four-sided figure, if you put square or rectangle, I marked it wrong. Because a square and a rectangle is a very specific type of quadrilateral. A square is a quadrilateral with four congruent sides and four right angles. If we know that, we're going to name it a square, not a quadrilateral, because it is a more specific definition. Now, before we get there, we're going to start talking about parallelograms. It's just a four-sided figure with two sets of parallel lines. Now, with parallelograms, we have two pieces of information that are going to go with it. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So we can fill that in with theorem 7.3. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So the opposite sides are going to be congruent. And this works out because if two lines are parallel, they never cross the internet, never intersect. They don't get any closer to each other. So the distances away from them should always be the same. So for this here, if a quadrilateral is a parallelogram, then the opposite sides are congruent. What also means if a quadrilateral is a parallelogram, then its opposite angles are congruent. Not only the opposite sides are congruent, but the opposite angles are congruent. So these here are two kind of basic theorems that we're going to look at so far with parallelograms. We have a few more things that we're going to look at with diagonals. And right now, if it's a parallelogram, the opposite sides are congruent, and the opposite angles are going to be congruent. Okay. Let's look at this here. Let's find the values of x and y. So for starters, ABCD is a quadrilateral because it has four sides. If it has four sides, it's a quadrilateral. Now, I also see that we have two sets of parallel lines because of our little arrows. It's saying that those sets of sides are parallel. So that means it is a quadrilateral. Two set is parallelogram. Since the quadrilateral has two sets of parallel sides, it makes it a parallelogram. If it's a parallelogram, it means the opposite sides are what? The same. They're going to be congruent. So if I wanted to mark on the figure, we can say that these two are going to be congruent, and these two are going to be congruent. We also know what? The angles, the opposite angles are going to be congruent. It means this angle and this angle are congruent, and these two angles are congruent. So that's just what we know because it's a parallelogram. Now what they want us to do is to find the values of x and y. Well, angle y is equal to what? The angle, the angle opposite, which would be 65. Okay? So we can go and solve for the value of y. Well, we did. Y is 65. There's nothing we need to do with that there. That's it. That's done. Y is 65 degrees because the opposite angles are congruent. Now, we also know the opposite sides are congruent. So x plus 4 is going to equal what? 12. Well, x is 8, yes. Because the opposite sides are congruent, so x plus 4 is equal to 12. And, well, we just need to solve by subtracting 4 from both sides, which will, yes, tell us that x is equal to 8. And that's it. So we can use these properties to solve for missing sides and missing angles. Questions on this here? All right, let's look at another one. So this here is a quadrilateral because it has 4 sides. And again, we have 2 sets of parallel sides, so we know that the opposite sides are congruent. It also means that the opposite angles are going to be congruent. And that's going to help us solve for the values of x and y. So I see 2x is one of my angles. And it here is going to equal, well, 54 degrees because 2x and 54 are opposite angles inside the parallelogram, so they are congruent. We also have that 3y minus 1 is one of our sides. And because it's one of the sides of the parallelogram, its opposite side is congruent to it. So 3y minus 1 is going to be equal to 20 because those 2 sides are congruent. They're going to have the same length. And now that we have this, we just need to solve for the value of x and solve for the value of y. Once we do that, we are done with this problem here. So when we look at this here, 2x equals 54. Well, to solve this here, I'm just going to divide both sides by 2. 2 divided by 2 simplifies to 1, so we get x is equal to, well, 54 divided by 2, so we get is 27. And that's the value of x. Now we're going to have to do a little bit more here to solve for the value of y. So the first thing we'll need to do is add 1 to both sides. Because negative 1 plus 1 is 0, leaving us with 3y is equal to 21. And last but not least, we would divide both sides by 3. It is. So y is equal to 7 and x is equal to 27. And that's it. That's all we have to do for this here. Any questions on this here? Any questions on anything we've done thus far? Okay, so we want to find the measure of angle G and the length of FG. Well, it's a parallelogram, so the opposite angles are congruent, yes? So angle G, what angle is opposite angle G? Angle E, which is 60, so it means angle G has to be 60 degrees. Now we also want to know the length of FG, this line right here. So the length opposite, the opposite sides are congruent. So what would FG be? 8. And that's it. Questions on this here? All right, I think we've got this. So we'll move on. to our next theorem. Now this is kind of going back to last semester when we talked about alternate interior, alternate exterior, consecutive interior angles. And it says that consecutive interior angles theorem states that if two parallel lines are cut by a transversal, then the pair of consecutive interior angles formed are supplementary. We remember working on this here, yes? Pair of consecutive angles in parallel lines is like a pair of consecutive angles between parallel lines. So it's just two angles that are between parallel lines, yes? That's all it's saying. Two angles between parallel lines add up to be 180. Wait a minute. In a parallelogram, I have two sets of parallel lines, yes? So the angles that are next to each other, the consecutive angles, x and y here, are between parallel lines, yes? So that means that, well, the consecutive angles inside of a parallelogram are going to be supplementary. The angles that are next to each other will always add up to be 180. So our consecutive angles, the ones next to each other, will add up to be 180. The angles that are across from each other are going to be congruent. And it's going to work every single time. So really looking at this here, in a parallelogram, how many different angles will we have inside the parallelogram? 2, because the opposite angles are congruent. The consecutive angles are supplementary. So we'll only really have 2 angles, 2 unique angles. And the last theorem, this is not as kind of straightforward, is if a quadrilateral is a parallelogram, then the diagonals bisect each other, they cut each other in half. So if PQRS is a parallelogram, then QM is congruent to SM, and PM is congruent to MR. So the diagonals bisect each other. They're not going to be the exact same. The diagonals aren't going to be congruent for parallelograms, but they will cut each other in half. So from where that, yes, sir. So where they intersect will be the midpoint for each diagonal. No matter how long they are, it will be the midpoint. And we're going to look at some problems dealing with this here. Now this first problem here is not too bad. We're just wanting to find all of the missing angles. Now looking at this here, we have 3 missing angles, V, W, and X. Which one do we know for sure without doing any math? Well, we know what W is. What is the measure of angle W? 80, because the opposite angles are congruent. The consecutive angles are what? They add up to 180. They're supplementary. To angle V, I'll call it X. So X plus 80 is equal to 180, the consecutive angles. So angle V plus, what did we use? Angle W or angle U? It doesn't matter. It doesn't matter because V and U, these here are consecutive angles, yes? So they add together to be 180. W and V are supplementary angles. They add together to be 180, yes? So either way I go, I'm getting the same angle. So to solve this, what do we do? We add minus 80 from both sides. And we get X is equal to 100. So angle V is 100 degrees. Yes? Any questions on this here? Now what do I need to do to find the other missing angle? Well, this angle is going to be 100 because, again, the opposite angles are congruent. And that's it. Questions on this here? Any questions on any of this here so far? We good with this here? Move on to the next problem. Okay, so angle L is 98 degrees because opposite angles are congruent. So how many other angles do I really need to solve for? One, because if I find the other angle, I know the angle opposite it. Well, these two angles here add together to be what? 180. So we can say our missing angle plus 98 is equal to 180. And really, we're just going to subtract 98 from 180, which would give us, or should give us 82 degrees. So 180 minus 98 would give us 82. So our two missing angles are both going to be 82 degrees. And that's it. That's all we have to do for this here. We'll go on and move on, but I will tell you that this is 70 and 110, because I feel like y'all have got the hang of this, yes? Opposite angles are congruent. To find the ones next to each other, we can subtract it from 180 for these here. Now this one here looks like we changed everything up, yes? Because we cut the figure in half. Now again, it's not drawn in, but we're using the assumption that these are all parallelograms because this section, or what we're doing today, is on parallelograms, yes? So normally we would need the parallelogram, the parallel sides, but we're going to assume that it is a parallelogram. Otherwise it wouldn't make any sense putting it in here. But this here is a parallelogram. So we're wanting to find this one here specifically first, because they gave us a question mark. Because these angles as a whole, 52 and that one that we don't know, and 60 are still consecutive angles. They're next to each other. Now the question mark angle and 52 are really together. But those two angles together, so 52, and we'll call it x, plus 60 would equal 180. Because consecutive angles, even if it's cut in half, we still just combine them back, will equal 180. So we'll have to do a little bit more work on this one. Well, 50 plus 60, 52 plus 60, 112. We can subtract 112 from both sides. And I believe it should be 68. So that missing angle here is 68 degrees. Well, what do we know about angle Y? Well, it is 60 because, again, opposite angles are congruent. Yes? Okay. Well, now we're just left with those two angles up here at the top for angle V. Yes, for angle V. And we'll need to find those. It may not ask for it on some of the homework to go all the way in this depth, but let's do it. We could. One thing we know for certain that this figure here is what? A triangle. The sum of the interior angles of any triangle is 180. I know two of the angles. I know one of them is 52 and one of them is 60. This looks very similar, doesn't it? All 52 and 60 is 112. So a little bit of deja vu here. So X is 68, so this angle here is and it works out that these two triangles are similar, not the exact same, but similar. And that's it. Questions on this here? Any questions on anything we've done thus far? All right, we're going to do one more of these. It's very similar to it. Now again, we know that 55, the question mark, and 62 are consecutive angles, so they add together to be 180. So we can say 62 plus x plus 55 is equal to 180, because again, consecutive angles add together to be 180. But we can add the 62 and 55 together, so we can combine like terms. That'll give us 7. 117. Well, to find the value of x, we need to get x by itself, so I would subtract 117 from both sides, because 117 minus 117 is 0. So our missing angle here is 63 degrees. This angle down here is going to be 55 degrees. What would our two other angles be? It'd be switched, right? Because this is 63 degrees, so this here is 63, and this would be 62. So this one and this one here, with these lines here, are going to be opposite interior angles. Our definition of parallel line, the opposite interior angles are congruent. And we'd really use this line and this line here for our 62s, because those would be opposite interior angles, so they would be congruent. Questions on this here?
This one, couldn't we also use the side, triangle, congruence?
Yes, we could, but if it would really require us to know the other sides. It does work out that they are going to be congruent because of our side angle side. But we could get there, yes. I'd be hesitant to use side, 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 because the only real side that I can say for certain is side length BD, because it's congruent to itself. I would need a little bit more information on the other two. But we would get there eventually, because we could use the other ones to eventually get to saying that all sides are congruent. Does that make sense? Mathematics is a little bit nitpicky when it comes to things, certain things. All right. Let's look at this here. This one here is a little bit more challenging, not a lot, just a little bit, because they didn't give us numbers, because the last few they just told us this is the angle measure. This here they told us angle U is 9x plus 15. Angle V is 6x plus 15. But what do I know about U and V? They, what? Equal 180. They add together to be 180. So if I want to find the missing angles, I have to find the value of x first. But because they're consecutive angles in a parallelogram, they add together to be 180. So 9x plus 15 plus 6x plus 15 is equal to 180. Now we can combine like terms. 9x plus 6x is going to be 15x. 15 plus 15 is going to be plus 30 is equal to 180. So we just combined like terms. Now we need to get x by itself. So the first thing I can do is we can subtract 30 from both sides. So 30 minus 30 is 0. So I have 15x is equal to 150. Last but not least, what do we need to do? Divide by 15. And we get x is equal to 10. That's what it asked for. Yes, find the value of x. No, what it asked for. Find the missing angle. So what do I need to do? We need to plug it back in. We need to plug it back in. So we can do 9 times 10 plus 15. Well, at this point here, we can type that all into the calculator, yes? 9 times 10 plus 15. Or I can do it by hand. 9 times 10 is 90, and 9 plus 15 is... So angle U is 105 degrees. We also know angle W is 105 degrees. So how can I find the other angle? There's two options. Option number one is what? Six times 10 plus 15, we can plug it in, yes? 6 times 10 is 60, plus 15 is 75. Or we could subtract it from 180 because consecutive angles add together to be 180. So that's our answer. Now again, like I said yesterday, how we can sometimes check it, like with the angles, because when we solve for the 4 angles inside of a triangle, when we had x, 2x, 5x, and 7x, I said we could add those together and see if they equal 360, just to make sure. We could do the same thing here. If I plugged them both in and checked, I can go back and make sure it does 105 plus 75 equal 180. It does, so we got the right answer. If it didn't, then we would need to go back and look back at our work and see what happened. Any questions on any of this here? Any questions on any of this here so far? Are you ready for the next problem? Yes? Okay. Now we're going to talk about these diagonals. Now this here tells me that Km is 23.4. Find Ym. Well, Km is the whole length. Now, since this is a parallelogram, it's not written in, but this is a parallelogram, we know that the diagonals do what? They bisect each other. They cut each other in half. So that means this length here is going to be the same as this length here. It cuts it in half, so that means we can take the full length and do what? Divide it by 2. Is 11.7. Because Ym is equal to half of Km. It's half of the whole. Questions on this here? This one here tells me RT is 19.8. Okay, 19.8. Find R. Okay. Let me back up. Let me put that on the right line. RT, 19.8. We want to find RP. I want to find the whole thing. Well, if I know RT is 19.8, they're diagonals inside a parallelogram. It means that TP is what? 19.8, because these two are congruent. Diagonals inside of a parallelogram bisect each other. They cut each other in half. So they're going to be congruent. So I can set it up this way, and we can do what? 19.8 plus, or I can say 2 times 19.8, because each one of these individual lines, the whole line is twice one of these lines. We cut it in half, so we divide it by 2, or we can double one of them to get the whole. 39.6. Yeah. I know, I really should. Hope you'll learn a few things, at least for a few weeks. Sometimes my brain gets it faster than I think. Because I'll work some of these problems out, and I'm like, okay, and then I'll get that answer in my head. Like this one here, 39.8, and I'll sit there. Oh, yeah, okay, it is right. Yeah, they're being absorbed. Are there any questions on this here? We're good with this here? We like this so far? Let's look at this one here. So made it a little bit harder. We're just utilizing these properties a little bit more. We're told that UH is 19. The whole length is 5x minus 7. Find the value of x. Well, that kind of stinks, because if it just asked me to find the length of FH, well, I can figure that out, because we're doing what? We take 19 and times it by 2, yes? The whole length will just be 2 times 19. But it didn't ask for that. It asked for the value of x. So 2 times 19 is going to be the same as what? 5x minus 7, because 5x minus 7 is the whole length of what we're trying to find. Yes? Questions on how we set this up? Okay. Well, now we just need to solve. Well, 2 times 19 is 38. Well, we need to get x by itself, so the first thing we would do is add 7 to both sides. Well, negative 7 plus 7 will be 0. 38 plus 7 is 45. And the last thing we need to do is to divide both sides by 5. And the value of x is 9. The value of x is 9. Questions on this here? Any questions on any of this here? We good with this here? Let's kick it up one more notch.
Wait, did you finish it?
Yeah.
Did I get...
X equals 9. Because if we plugged it back in,
Never mind, I thought we were still trying to find it.
no, if we wanted to find FH, it would actually have been easier to find it than doing that. Because if this one part is 19,
I thought you were going to want to show our work.
well, that would be the work right there. Yeah, because the whole length would have been 38. We'd been done. So this one here is just find the value of x. Now we're doing the exact same thing, except instead of giving us a number and an equation, it gave us 2 equations. So let's see what equations it gave us. So KU is 3x plus 3. So this length here is 3x plus 3. And we're told UM is 4x minus 4. Well, wait a minute. Those two sections are what? The same. They're equal. So I can set them equal to each other because KU is equal to UM. Because the diagonals inside a parallelogram bisect each other. So these would be equal. So 3x plus 3 is going to equal 4x minus 'cause the diagonals inside of a parallelogram are equal. If I want to find the value of x, I need to get x on the same side of the equal sign. I'm going to subtract 3x. There's nothing wrong with subtracting 4x from both sides, but I try to keep the value of x positive if at all possible. 3x minus 3x will simplify, leaving me with 3 is equal to, well, 4x minus 3x would be x minus 4. And last but not least, we need to add 4 to both sides, telling us that x is equal to 7. That's it. Sit with that there. And I believe that's the end of the notes. And that's it. That's all we have with this here. Now, I was expecting a little bit that problem to be harder than what it was. For some reason, I had it in my head that they were saying that one of these links was the whole, but it wouldn't be any different than the one we did before it, because I can multiply one of them by 2 and set it equal. If you remember back to the chapter before we went on break, where we talked about the 1/3 and 1/2, or 1/2, the bigger, the smaller is half the bigger is twice the smaller. We could do the same thing there.